Good evening, everyone. Today, I am going to present my ATT Tech Talk. I am Karthik from AAA department. The subject mathematics and the topic is diagonalization of a complex matrix. The introduction. A square matrix A is called diagonalizable or non-defective if it is similar to a diagonal matrix. That is, if there exists an invertible matrix P and a diagonal matrix D such that P minus 1 into AP equals to D, or equivalently A equals to P into D into P minus 1. Algorithm of diagonalization. Find the distant eigenvalues of A. Find n linearly independent eigenvectors V1, V2, and so on up to Vn corresponding to the eigenvalues of A. From the matrix P with Vi as column L equal to 1, 2, 3, and so on to n. If P is orthogonal, then P into T into A into P equal to P minus 1 into A into P is the required diagonal matrix. The diagonal entries begin the eigenvalues x1, x2, x3, so on up to xn, corresponding to the eigenvectors v1, v2, v3, so on up to vn respectively. This is the algorithm of diagonalization. It's like a linear map T is to V. If V is diagonalizable if and only if the sum of the dimensions of its eigenspaces is equal to dim of V, which in this case, if and only if there exists a basis of V consisting of eigenvectors of T with respect to such a basis, T will be represented by a diagonal matrix, are given by the eigenvalues of T. Next, the fundamental fact about diagonalizable maps and matrices is expressed by the following ways. A of matrix n into n matrix A is over a field phi is diagonalizable if and only the sum of the dimensions of its eigenspaces is equal to n, which is the case if and only if there exists a basis of f bar n into n consisting of eigenvectors of A. If such a basis being found, one can form the matrix P, having these basis vectors as columns and P minus 1 into A into P will be a diagonal matrix whose diagonal entries are eigenvalues of A. The diagonal matrix P, the matrix P is known as model matrix of A. The next slide. A matrix is diagonalizable over the field if it has distinct eigenvalues in, that is, if its characteristic polynomial has distinct roots in, that is, however, the converse may be false considered. These are the elements in the matrix which has eigenvalues. If we solve this matrix, we get the eigenvalues, this type of eigenvalues, 1 comma 2 comma 2 are the eigenvalues of this matrix. Not all distinct and is diagonalizable with diagonal form, similar to the principal diagonal elements should be, other than the principal diagonal elements, all should be the zeros. Next. And change of basis matrix P. The matrix P is there 1 comma 1, 1 1 minus 1 1 1 0 1 0 3. The converse fails when A has eigenspace of dimension higher than the 1. In this example, the eigenspace of A is associated with the eigenvalue 2 and has a dimension of 2. At last, we go to the conclusion. Diagonalization of a complex matrix is the technique of finding diagonalization of a matrix. Matrix is the process that is very important topic in all engineering fields, and diagonalization play a key role in it. In matrices, diagonalization is plays a major role. Thank you, everyone. Thank you.